Welcome to section 7.2. We're going to be working with exponential decay today. This is a lot like section 7.1, where we're going to start with that basic equation that says y equals ab to the x. The only difference, yesterday exponential growth, our b value here was bigger than 1. In exponential decay, our b value has to be between 0 and 1. Now this can be a fraction, a decimal. Most of the time you're going to see it in fraction form, but if you convert it to a decimal, just make sure your decimal is between 0 and 1. I also want to talk about this general form and the transformations that it does. We looked yesterday at this equation a times b to the x minus h plus k. And so I want to talk about this general form and what it does again. We talked yesterday that h moves it either left or right, but the hard part when it's in the exponent or when it's tied with the x is it's opposite of what you think. So if it says plus a number, you're actually moving it left. If it says minus a number, you're actually moving it right. The k value tells you if you move up or down. Okay, and then the a value does multiple things for us. And so let's talk about a couple. If a is greater than 1, it's a stretch. If a is between 0 and 1, we said yesterday this is a shrink, which means it shrinks it closer to the x-axis. The last thing is if a is negative, it's going to reflect over the x-axis. Okay, and you do need that phrase as you describe the transformation. Okay, we also talked about that a value being part of our y-intercept, and I'm going to show you that kind of as we go through. So here's what I'm going to do. I'm going to move this over, and let's look at two examples first. You will have to do an example on your own. But let's take a look. I'm going to slide a 1 right in front of here so that I know that my a value tells me my y-intercept occurs at the point 0, 1. So I can at least plot that y-intercept on my y-axis. Now, I'm going to start us off like we did yesterday, although I'm hoping at some point you get to use your calculator, but I'm going to show you just in case you don't have a graphing calculator. We're going to pick the values -2, -1, 0, 1, and 2. So as I look at this, I always start with the 0, because anything to the 0 power is just 1, and if I multiply that by 1, I get 1. If I look at 1/5 to the first power, I get 1/5. If I look at 1/5 to the second power, according to my exponent rules that we did in chapter 5, I can distribute the exponent to top and bottom. So 1 squared is 1, 5 squared is 25, so it's 1 over 25. Negative exponents do the reciprocal, so 1/5 to the negative first means it's 5 over 1, or just 5. And again, -2, you take the reciprocal and then you square it, so I get 25. So I'm going to plot these points. At -1, I go up to 5. At 0, I have 1. At 1, I have 1/5, and then 1/25, and we see that these values will start getting smaller and smaller and smaller and smaller, and we said they would get really close to the x-axis. Now, like we did before, I want to change colors, and I want to draw in my asymptote. Okay, and we said our asymptote should be the dotted line, because again, it's not going to touch the x-axis. So let's talk about the asymptote. The asymptote has the equation y equals 0. My domain, I put in negative numbers, 0, and positive numbers, so my domain is all reals. My range, you'll notice all of the y values are above my asymptote, so we say all reals greater than my asymptote, which my asymptote occurs at 0, so all reals greater than 0. In this case, because my y-intercept still is at 0, 1, there is no transformation. This is the basic function. But some of the other ones that we look at will have a transformation. Okay, so we're going to look at example 2. If I take a look at example 2, you'll notice now there's a 3 in front. That changes my y-intercept to 0, 3. And you'll notice now instead of being at 0, 1, it's at 0, 3, which is away stretching away from the x-axis. So we want to automatically stick in here, it's a stretch of 3. Now I don't know if there's more transformations at this time, but we're going to start there. Okay, you again could make a table if you needed. And if I look at this, I'm going to stick with my handy dandy -2, -1, 0, 1, and 2 values. Anything to the 0 power is 1. So 2/3 to the 0 power is 1. Multiply it by 3, you get 3. 2/3 to the first is 2/3 times 3 makes 2. 2/3 squared is 4/9. And 4/9 times 3, let me write this down so you can kind of see what I'm thinking. 4/9 times 3, it's like saying 3/1, and so this ends up being 4/3. Okay, if I take the reciprocal power, then 2/3 to the -1 is 3/2, and so 3/2 times 3/1 is 9/2, or if you want 4.5 is fine, it's the same thing as 9/2. And you could keep going. If I square the reciprocal, I get 9/4, and then I multiply by 3/1, and I end up getting 27/4. Okay, now this is going to be bigger than what we can put on our graph, but let's kind of look. At -1, 4.5. At 0, 3. At 1, 2. At 2, it's about 1 1/3, and you'll notice that it'll start going down and down and down. Now, I didn't shift my graph either up or down or left and right, so my asymptote will still stay at the x-axis. So let me put in my asymptote. Because I didn't move left or right or up or down, my asymptote stays the same, so my asymptote is at y equals 0. My domain, again, is all reals, because I have a negative, a positive, or 0 and a positive. My range is again above my asymptote, so all reals greater than 0. Okay, for the next one, I'm going to slide over to example number 3, but I'm going to assume that we're using our graphing calculator for number 3, so I'm not going to be making the table, but if you need the table, stop this video at one point and actually make the table then. Because of this a value at -2, I know my y-intercept is at 0, -2. So I'm going to plot that point. Okay, again, I'm not shifting left or right or up or down, so my asymptote is going to stay at y equals 0. But I can at least talk about what the -2 does in terms of my transformation. The negative itself says reflect over the x-axis. Okay, the 2 moves it away from the asymptote, so then it has a stretch of 2. So in this case, there are 2 transformations that come from the -2. What I actually can do should be able to fill in the rest. I'm going to be able to put all reals into my domain, because I can take negative exponents, positive exponents, and 0. And in this case, you'll notice my points will always be under the asymptote, so all reals less than my asymptote of 0. Now, to get the rest of the points, I'm just going to plug this in my grapher, and I'm going to kind of look at what my grapher has to say. And so I'm going to put a couple of dots in here to show you kind of where you should be able to find values. It looks like about here, and here, and here. And again, I'm taking these kind of right off my grapher. And my graph looks something like this. Now you'll notice not only did it reflect, but it's also farther away from my asymptote, or the x-axis, than it was at the point 0, 1. Now, one thing you should notice, and I'm going to stretch these out a second, one thing you should notice as you're doing this is the difference in the look of the graph. If you look in this section, we're talking about decay, and so our graph goes down. It starts high and then goes down as it gets close to the x-axis. Where when we did growth, it went up. We started by the x-axis as we read from left to right, and it went up positive. And so at least no matter what, you should be able to look at an equation. And if an equation has a base, that's either a fraction or a decimal, under 1, you should think, okay, that's a decay. If the number of the exponent, the base of the exponent is a number bigger than 1, then you should be thinking growth. Okay, and growth should look something like this. And so kind of keep that in mind. We want you to recognize these as you go through. Now what I want you to do is flip the page, and we're going to ask you to do a couple more challenging. But this one I would like you to do on your own. In order to get the points for the notes, that needs to be completed. You can do so with a table or you can use your grapher. Kind of up to you. Okay, so let's slide. Now, in page 2, here's what we're doing. What we are doing is doing a lot more shifting. We're not only going to stretch and shrink, but we're also going to move it left and right and up and down. Okay, so again, you kind of want to look back at this. Now, what I'm going to do is I'm going to kind of make this a little bit bigger so we can see this. And I'm going to start with example 1 and have you do example 2 on your own. Okay, so this one is an on your own question. That also has to be done before you come to class. Now let's take a look at question number 1. Let's start with what we know. Instead of this y-intercept, I'm going to change this like we did yesterday. And my starting point is going to be 0, 2. Now the reason I call it the starting point is because I'm now going to shift my graph left or right and up and down. So let's start there. 0, 2. I don't necessarily want to put this dot on there, but I'm going to in a minute. But here, let's go through. The 2 says I'm going to stretch myself away by a value of 2. Now let's go to my equation. This plus 1 at the end is the k value, so it says go up 1. And this minus 1 in the exponent is the opposite of what we think, so we're really going right 1. Okay, now I'm going to actually kind of draw 2 different graphs because, again, I think it's a little bit easier. So I'm going to draw the original, and the original graph I'm going to do in blue, and that's 2 times 3/5 to the x. Okay, so my original point is at 0, 2, and I'd have an asymptote, and I don't really want to put that in, but just a little bit. I'd normally have an asymptote at the x-axis, or the y equals 0 line. And what I want to do then is I'm going to end up shifting some points. Okay, now this point would normally shift, according to what we said, up 1 and right 1. And so I'm going to change my color, and I'll kind of go back and forth. But if I go up 1 and right 1 from that point, this green graph is going to be my new graph. What I also know, and what we talked about yesterday, is this up 1 changes where my asymptote is. So this kind of dotted blue line is where the normal asymptote is. Because I moved it up 1, I'm going to change it so it looks something like this. Okay, so I'm going to fill this in. My asymptote is y equals 1. I can also fill in domain and range at this point. Domain, I can always do a negative exponent, a positive exponent, and 0, so my domain is all reals. And you'll notice my green graph, the point is already above the asymptote. So I'm going to say all reals greater than, and my asymptote occurs at 1, so it's greater than 1. Now you can just take these points directly off your calculator, and you would end up getting a graph that looks something like this. And I'm trying to approximate points, but you end up getting a graph that kind of comes down like this. Now if you need the blue graph, if you need this original graph, please do so. But my goal is, again, to be able to get you to get points right off your calculator, although all of this stuff I believe you should be able to do without a calculator. The graphing of the function, you might need the calculator for to find the decimals. I'm completely fine with that. But the rest of it, I think we've got to get into that understanding of what does it mean, what does this formula tell me, and how does it relate to domain, range, transformations, things like that. Okay? Now again, what I said to you is this bottom graph, I would like you to try on your own. Even if that means make a table or graph the original and then move it, you can do that too. But that is, again, something that I'm going to ask you to do before you come to class. Okay? I'm going to slide it over to get to our last topic. And our last topic is the exponential decay formula. Now yesterday in class we did the exponential growth. And so let's go through the decay. It's just like the growth, where I start with a times But instead of adding r, I'm going to subtract r because I'm decaying to the t. Let's go through what they mean again. A is going to be our starting amount. Okay, and that means, oh, I don't want to use money because it's not always going to be money. Let me go to starting number. Okay, our R is our rate, but the important part of our rate is it has to be as a decimal, so we'll take our percentage and divide by 100. And T, again, is our time. And most of the time, our time is in years. But let's go through one of these. A new TV costs $1,200 when you purchase it. The value decreases, means minus, by 21% each year. So as I start out, I'm looking at 1,200 times 1 minus 0.21. And again, take this and divide it by 100 to get your decimal to the T. Or X, I'm okay with either one. But this is the idea. Now what your book does that's different, okay, and I'm perfectly fine with this answer. But what your book does is says, why would I say 1 minus 0.21 when I could just actually find 1 minus 0.21 and tell you it's 0.79. The reason I kind of like this is because you'll notice our base is between 0 and 1. So that should tell me that I'm decreasing or doing a decay function. Okay, so let's slide this up just one more, and then we're all done for section 7.2. But if you take a look, you purchased a 2010 Honda Civic. Let's put in an amount, shall we, for $10,000. It depreciates in value each year by 2.35%. Okay, so if I take 2.35 and I divide it by 100, that'll get me my decimal. So let's start with our equation. We started by paying $10,000 for this Honda Civic, and I do 1 minus because depreciate means decreases. When I take 2.35 divided by 100, I get 0.0235 to the T. Okay, so my general equation to model means use my variables. Now, how much is the car worth in 8 years? Y equals 10,000. 1 minus 0.0235 to the 8th. Stick that in your calculator and give me a decimal. And I'm going to check this decimal when you come in tomorrow. The biggest thing, though, is when you're dealing with money, you need to round only to 2 decimal places. Okay? So when you come in, I'm asking 3 things of you. One is the example number 4 on the front. The second one is example number 2 at the bottom. And I want you to give me this decimal amount when you come in as well. So that's section 7.2. We'll practice again for 7.3, but please make sure you have those 3 things done before coming to class.